What if I told you that the fastest way your body burns sugar is not through long walks, not through sweating for miles, but through something quieter, simpler, and deeply biological, something your muscles were designed to do long before treadmills ever existed? Inside your body, sugar is not the enemy. It is fuel. The real question is not how much sugar you eat, but how efficiently your body knows where to send it. And that decision is made every single day by your muscles. Muscles are not just for movement. They are one of the largest metabolic organs you have. When they are active, they behave like open doors, pulling sugar out of the bloodstream without even asking much from insulin. This is not motivation, this is physiology. Here is the habit that changes everything. Brief daily muscle activation through resistance-based movement. Not intense workouts, not gym culture. Just waking your muscles up and asking them to work against resistance, even for a few minutes. When muscles contract under load, they trigger a powerful cellular response. Glucose transporters move to the surface of muscle cells, and sugar flows out of the blood and into storage where it belongs. This process happens faster and more directly than walking, because walking relies primarily on endurance metabolism, while muscle work directly empties glucose from circulation. Walking is gentle and beautiful, but it burns sugar slowly. Muscle activation burns sugar decisively. It tells the body, "We need fuel now," and the body listens. Even light resistance, standing up and sitting down repeatedly, wall push-ups, slow controlled movements, sends a signal deep into your metabolic system. The signal says efficiency matters, strength matters, readiness matters. There is something deeply human about this. As we age, we lose muscle not because time demands it, but because we stop asking muscles to participate in life. And when muscle disappears, sugar lingers in the blood longer than it should. Blood sugar problems are often muscle problems in disguise. This is not failure. It is neglect, unintentional, reversible neglect. What makes this habit so powerful is not intensity, but consistency. Muscles remember what you ask of them daily. Each contraction improves insulin sensitivity for hours afterward. Each day you activate muscle, you create a longer window where sugar is cleared efficiently. Over time, the body relearns balance, not through punishment, but through cooperation. And perhaps the most profound part is this: resistance movement restores dignity to the body. It reminds the nervous system that the body is capable, that it is useful, that it is alive. Health is not built by chasing exhaustion. It is built by sending clear signals to the body about how it should function. Muscle activation is one of the clearest signals we can give. When you choose this daily habit, you are not exercising to burn calories. You are training your body to manage energy wisely. You are teaching your cells how to behave again. And that quiet conversation between muscle and blood sugar may be one of the most powerful acts of self-care available to us. Most people think of muscles as tools for movement, something that helps us walk, lift, or maintain posture. But biologically, that idea is far too small. Muscles are not passive structures waiting for instructions. They are one of the most powerful metabolic organs in the human body. In fact, skeletal muscle is responsible for handling the majority of glucose that enters the bloodstream after a meal. When you eat carbohydrates and your blood sugar rises, nearly 3/4 of that glucose is meant to be absorbed by muscle tissue. This means that muscles are not just responding to sugar, they are managing it, deciding whether it will be used, stored, or left circulating where it can cause damage. When muscles contract, they create an immediate demand for energy. This demand sends a signal at the cellular level that glucose is needed right now. In response, special transport proteins move to the surface of muscle cells and pull glucose directly out of the blood. What makes this remarkable is that this process does not rely heavily on insulin. Even when insulin sensitivity is low, active muscle can still absorb sugar efficiently. This is why muscle activity is such a powerful tool for blood sugar control, especially for people struggling with insulin resistance or type 2 diabetes. Walking, while beneficial and gentle, operates differently. Walking is primarily an aerobic activity that uses oxygen and burns fuel at a steady, slow rate. It is excellent for circulation, mental clarity, and cardiovascular health, but its effect on rapid glucose clearance is modest. Walking burns sugar gradually, spreading energy use over time. Muscle-focused movement, on the other hand, creates an urgent metabolic need. The body prioritizes feeding active muscle, and glucose is cleared from the bloodstream more quickly and more directly. From an evolutionary perspective, this makes perfect sense. Human survival depended on short bursts of strength lifting, carrying, climbing, pushing, standing up repeatedly. These actions required muscles to be metabolically alert. The body evolved to treat muscle contraction as a signal of immediate need. Blood sugar rose after eating so that muscles would have fuel for work. In modern life, when muscles are rarely challenged, that ancient system becomes confused. Sugar still arrives, but muscles do not ask for it, so it lingers in the blood. This lingering sugar is not harmless. Elevated blood glucose stiffens blood vessels, damages nerves, strains the pancreas, and accelerates aging at the cellular level. What is often blamed on diet alone is frequently a mismatch between sugar intake and muscle demand. Without active muscle tissue, the body loses its primary sugar sink. The bloodstream becomes a waiting room for glucose that has nowhere to go. Another critical aspect is muscle mass itself. Muscle is metabolically active even at rest. The more muscle you have, the higher your baseline glucose uptake throughout the day. This means that muscle is working for you even when you are sitting, breathing, or sleeping. Walking improves fitness, but it does little to preserve or build muscle mass unless combined with resistance. Muscle-focused movement protects and maintains this tissue, keeping the metabolic engine large and responsive. There is also a neurological dimension. Muscle contraction improves communication between the brain and the body. When muscles are engaged, the nervous system becomes more efficient, improving coordination and hormonal signaling. This enhances glucose regulation beyond the muscles themselves, influencing the liver, fat tissue, and pancreas. Walking offers some of this benefit, but resistance-based muscle use amplifies it. Importantly, muscle activation does not require heavy weights or intense workouts. The metabolic response is triggered by tension, not exhaustion. Slow, controlled movements, bodyweight exercises, or even repeated sit-to-stand motions create enough stimulus to wake up glucose-handling pathways. This makes muscle activation accessible to older adults, beginners, and people with limited mobility. Perhaps the most overlooked truth is that muscles protect independence. When muscles weaken, blood sugar rises, energy drops, and fatigue increases, creating a cycle of inactivity. Strength preserves movement, movement preserves metabolism, and metabolism preserves health. This is why focusing on muscle is not about appearance or performance, but about restoring the body's natural ability to regulate itself. When we understand muscles as a metabolic organ rather than a cosmetic one, exercise stops being punishment and becomes communication. Each contraction is a message to the body saying energy is needed, balance is required, systems must cooperate. This conversation between muscle and blood sugar is constant, subtle and powerful, shaping health day by day in ways that are invisible but deeply transformative, influencing how the body ages, adapts, and responds to the simple act of living. Muscles do far more than move the body. They act as the body's most efficient sugar regulators, and the mechanism by which they do this is profoundly elegant. When muscles are activated under resistance, Whether through lifting, pressing, or even slow bodyweight exercises, they pull glucose out of the bloodstream directly, using a process that is both precise and rapid. This process relies on glucose transporter proteins, known as GLUT4, which are stored inside muscle cells until contraction signals them to move to the cell surface. Once at the surface, these transporters act like gates, allowing glucose to flow from the blood into the muscle, where it can be used immediately or stored as glycogen for future energy demands. What is remarkable about this system is that it works largely independently of insulin. While insulin is the hormone most people associate with sugar regulation, muscle contraction creates an alternative pathway, allowing glucose to enter cells without requiring high insulin levels. This means that even in individuals with insulin resistance, active muscles can still clear sugar effectively, offering a metabolic shortcut that walking or mild aerobic activity cannot achieve at the same intensity. The body's reliance on muscle for glucose regulation is rooted in evolution. For tens of thousands of years, humans survived through bursts of activity that required strength and power. When early humans hunted, climbed, or lifted, their muscles demanded fuel immediately, and the body responded by redirecting glucose to those active cells. This pathway allowed humans to perform physically demanding tasks without waiting for hormonal signals to catch up. Today, when muscle activation is minimal due to sedentary lifestyles, the same evolutionary mechanism is underutilized. Glucose remains circulating in the blood longer than necessary, contributing to metabolic stress, inflammation, and the gradual onset of chronic conditions. By intentionally activating muscles under load, we can tap into this deeply embedded physiological process, harnessing the same efficient glucose management system our ancestors depended on for survival. Resistance-based muscle activation is uniquely powerful because it targets multiple metabolic systems at once. While aerobic exercise improves cardiovascular endurance and slowly burns glucose over time, resistance movements create a direct, high-demand situation for sugar. This immediate demand triggers a cascade of cellular events. Muscles contract, GLUT4 transporters move to the surface, glucose enters the cell, and energy production ramps up. Simultaneously, the activation signals improve insulin sensitivity within the muscle, meaning future glucose uptake becomes easier and more efficient. These dual benefits, rapid glucose clearance and enhanced insulin responsiveness, highlight why muscle-focused activity can be more effective than walking alone for managing blood sugar. The science behind this is both intricate and fascinating. Muscles contain mitochondria, the energy factories of the cell, which convert glucose into ATP, the molecule that powers every contraction. When resistance is applied, the demand for ATP skyrockets, signaling mitochondria to consume glucose at a higher rate. This creates a temporary metabolic vacuum in the bloodstream, prompting glucose to flow from circulation into muscle cells. Over time, repeated activation increases both the number and efficiency of mitochondria, improving the muscle's ability to process sugar continuously. In contrast, aerobic activity primarily uses oxygen-dependent pathways for energy, which consume glucose more slowly and over a longer duration, meaning blood sugar reduction is gradual rather than rapid. Muscle activation offers a direct, almost surgical, approach to lowering blood glucose, emphasizing the importance of quality and intensity of contraction over sheer duration of movement. Even small amounts of resistance work produce meaningful effects. Simple exercises like wall presses, chair squats, or slow push-ups engage multiple large muscle groups and trigger GLUT4 translocation. This is particularly important for older adults or individuals with mobility limitations. While it is tempting to equate exercise effectiveness with long cardio sessions, the truth is that glucose regulation depends on signaling at the cellular level, not just energy expenditure. Activating muscles under resistance provides a strong metabolic signal with minimal time investment, making it an accessible and sustainable habit for almost anyone. There is also a systemic benefit. Muscle contraction not only clears glucose but also influences hormone levels, such as increasing the release of myokines, which improve communication between muscles, the liver, and fat tissue. These chemical messengers enhance insulin sensitivity throughout the body, reduce chronic inflammation, and improve lipid metabolism. Resistance-based movement therefore has far-reaching effects, helping the body manage sugar more effectively while supporting overall metabolic health. By contrast, walking, while beneficial for cardiovascular health and mood, primarily engages endurance metabolism and has a slower, less direct impact on blood sugar control. Another layer to consider is the relationship between muscle mass and glucose management. Larger, stronger muscles provide more surface area for glucose uptake, amplifying the effect of resistance-based activity. Each contraction, repeated daily, strengthens the muscle's ability to act as a metabolic sink, continuously clearing sugar even during periods of rest. This reinforces a virtuous cycle. Active muscles improve glucose handling. Improved glucose handling supports muscle function, and healthier muscles maintain long-term metabolic stability. In this sense, muscle-focused activity is both a preventative and restorative strategy, addressing the root of sugar regulation rather than merely treating its symptoms. Finally, the act of consciously activating muscles under resistance reconnects individuals to their own physiology in a profound way. It is a reminder that the body is intelligent, responsive, and capable of self-regulation when given clear signals. Walking is restorative, calming, and essential for overall wellness, but resistance-based movement speaks directly to the metabolic systems responsible for sugar management, sending a precise message that energy is needed, balance is required, and the body's innate systems must be engaged. This daily habit transforms muscles from passive structures into active partners in health, creating a tangible pathway to better sugar control, improved insulin sensitivity, and a stronger, more resilient body. Muscle activation does more than just move sugar from the bloodstream into cells. It fundamentally changes how the body responds to insulin, making every meal easier to manage and every bite less likely to overwhelm the system. Insulin is often portrayed as the star of blood sugar control, the hormone that shepherds glucose into cells, but insulin cannot act alone. Its efficiency depends on the responsiveness of the tissues it serves, and skeletal muscle is the primary stage where insulin performs its work. When muscles are active, they improve insulin sensitivity, meaning that even small amounts of insulin can move glucose effectively. This is a profound concept because insulin resistance is at the root of many metabolic problems, from type 2 diabetes to cardiovascular disease. Resistance-based muscle work essentially teaches the body to listen to insulin again, reminding the cells that glucose is welcome and can be used efficiently. The mechanism is subtle but powerful. During muscle contraction, signals within the cells alter the sensitivity of insulin receptors. The GLU4 transporters, which carry sugar into the cells, not only respond to contraction itself, but also become more receptive to insulin after repeated activation. This dual pathway, insulin-dependent and insulin-independent, provides a safety net, allowing the body to clear glucose both immediately and for hours afterward. This is why a short session of resistance movement can have effects that last well beyond the exercise itself, improving blood sugar handling for meals consumed later in the day. Unlike walking, which relies mostly on steady energy expenditure, resistance-based work communicates directly with the cellular machinery, ensuring that sugar has a clear destination and that insulin can perform its function more efficiently. There is a rhythm to this interaction between muscle and insulin that is both biological and philosophical. The body is constantly seeking balance, and insulin sensitivity is one of the most critical points of equilibrium. When muscles are neglected, insulin struggles, glucose lingers, and the body signals distress in the form of fatigue, cravings, and inflammation. By activating muscles daily, even for a few minutes, we provide a recurring reminder to the system this body is active, capable, and ready to manage energy wisely. Each contraction reinforces the relationship between muscle and insulin, gradually restoring a harmony that modern lifestyles often disrupt. From a practical standpoint, this is extraordinarily accessible. You do not need to lift enormous weights or train like an athlete to improve insulin sensitivity. Moderate resistance work, lifting household objects using resistance bands, performing bodyweight exercises like squats or push-ups, is sufficient to create meaningful changes at the cellular level. Consistency matters more than intensity. A few minutes each day, repeated over weeks and months, allows muscles to adapt, insulin sensitivity to improve, and glucose regulation to strengthen. This is an important insight for anyone who has felt intimidated by exercise, particularly those managing chronic conditions. Muscle work does not require extreme effort. It requires attention, persistence, and intention. The metabolic effects of enhanced insulin sensitivity extend beyond blood sugar alone. Improved insulin responsiveness reduces the stress placed on the pancreas, decreases the likelihood of fat accumulation in the liver, and helps regulate lipid metabolism. This creates a cascade of benefits, as the body is able to operate more efficiently across multiple systems. Muscle activation acts as a keystone, supporting the arch of metabolic health. Each session communicates a simple yet profound message: the body is capable of processing energy efficiently. The cells are listening, and balance is possible even in a world of constant dietary challenges. Neurological and hormonal responses also play a role. Active muscle tissue secretes myokines, chemical messengers that influence insulin sensitivity throughout the body. These myokines improve communication between muscles, fat tissue, and the liver, creating a network that supports glucose management beyond the cells directly involved in contraction. Resistance work, therefore, has systemic effects, reshaping the way the body as a whole responds to sugar intake. Walking or light aerobic activity contributes to circulation and cardiovascular health, but it does not trigger this intricate cellular conversation to the same degree. Muscle-focused activation ensures that insulin signals are heard and acted upon throughout the body. Muscle activation also has a preventative and restorative dimension. As we age, muscle mass naturally declines and insulin sensitivity tends to decrease as well. Resistance-based movement combats both processes simultaneously, preserving strength while maintaining metabolic responsiveness. This is particularly important for older adults, but it is equally relevant for anyone seeking to maintain long-term health. By training muscles to respond consistently to glucose and insulin, we are essentially training the body to remain resilient, adaptive, and metabolically intelligent. There is also a profound psychological benefit. Engaging muscles daily fosters a sense of control and agency over one's health. Insulin resistance can feel like an invisible force, difficult to manage through diet alone. Muscle activation provides a tangible way to influence metabolic outcomes. Each contraction is a deliberate act of care, a signal to the body that it is supported, capable. Over time, this creates confidence in the body's ability to manage energy, reducing stress and reinforcing healthy behaviors. Ultimately, the power of resistance-based muscle work lies in its ability to restore the body's natural efficiency. Insulin sensitivity is not static. It responds dynamically to our habits. Muscles are the primary interface through which these habits translate into measurable health benefits. By consistently engaging them, we create a system that can handle sugar intelligently, reduce the burden on insulin, and improve overall metabolic function. Unlike passive or purely endurance-based exercise, resistance work communicates directly with the cellular machinery, optimizing both immediate and long-term responses. This daily habit of muscle activation reshapes the relationship between the body and energy, allowing glucose to move efficiently, insulin to act effectively, and the entire metabolic system to operate in harmony. Muscle inactivity is often overlooked as one of the silent drivers of blood sugar imbalance, yet it plays a central role in metabolic health. When muscles are weak, underused, or neglected, the body loses its most effective sugar-clearing system. Blood glucose that would normally be drawn into active muscle cells lingers in the bloodstream, creating a cascade of consequences that extend far beyond energy management. This lingering glucose contributes to oxidative stress, inflames blood vessels, and interferes with normal hormonal signaling, slowly eroding the body's capacity to maintain balance. Muscles are not just passive storage units. They are active participants in regulating how sugar is processed and utilized. And when they are not engaged, the body struggles to manage its fuel efficiently. The connection between inactive muscle and poor blood sugar control becomes particularly apparent with age. As we grow older, muscle mass naturally declines, a process called sarcopenia, and the body's sensitivity to insulin diminishes. The combination of reduced muscle activity and declining insulin efficiency creates a perfect storm for elevated blood glucose. Yet this process is not inevitable. Muscles retain their ability to clear sugar efficiently if they are regularly activated, even lightly and for brief periods. Resistance work, whether through simple bodyweight exercises or light resistance bands, reawakens these dormant metabolic pathways. Each contraction sends a signal deep into the cells that glucose is needed and that energy balance matters. Over time, the cumulative effect of these repeated activations restores not only strength but metabolic control, highlighting the intimate connection between movement, muscle health, and sugar regulation. Beyond the biochemical mechanisms, the physiological consequences of muscle inactivity can feel surprisingly tangible. Fatigue, difficulty maintaining energy levels, and increased susceptibility to cravings are all reflections of muscles that are not performing their metabolic role. Muscles communicate with other systems in the body through hormones, chemical messengers, and neural pathways, influencing appetite, energy storage, and fat distribution. When muscles remain idle, this communication is weakened, leaving the body more prone to imbalances in blood sugar, insulin, and lipid metabolism. Resistance-based activity reignites this communication, producing myokines that enhance tissue responsiveness throughout the body. These chemical signals are like a conversation between muscle and organ systems, reminding the body that it is alive, active, and capable of regulating energy efficiently. Modern lifestyles exacerbate this problem. Sedentary behavior, long hours of sitting, and minimal engagement of large muscle groups mean that the body rarely receives the signals it needs to maintain sugar control. Glucose that would normally fuel movement accumulates instead, increasing the burden on the pancreas and fat tissue. Over time, this imbalance can lead to insulin resistance, weight gain, and metabolic syndrome. Resistance-focused movement addresses this issue at its root. By contracting muscles under load, even for short periods, the body is reminded that energy is required immediately. GUT4 transporters move to the cell surface, glucose flows into muscle, and insulin sensitivity improves. Unlike walking or gentle aerobic activity, which primarily burns sugar slowly, Muscle activation offers a targeted and direct pathway for clearing glucose quickly and efficiently. There is also a psychological dimension to consider. Muscle inactivity